Okay, so we have these quiz problems, 20% more than 40. Now, everybody got that rather quickly, but we write this out. We say 20% more than 40 is what? It's 40 plus 20% of 40. So that means it's 40 plus 0.20 times 40. And then that's easy to calculate. And you get 40 plus 8, which is 48. Everybody got that rather quickly. Okay, so what I'm asking people to do now is 20% more than the number 60. Write out a statement like 20% more than 60 is, or sorry, it's not 20% more than 60, 20% more than a number is. Okay, so like 20% more than a number is, but don't write 60, write a statement that tells you what it means to have 20% more than a number. And you're probably not real used to doing this, so that could be a little bit challenging. We'll see how everybody does here in a minute. Let's get the camera zoomed in because it just decided to go someplace else. Not as bad as it usually does. Okay. Trying to hit the pause button here. Okay, so it did pretty well. But as I said, it's kind of an art learning to put the right words in something so you can clarify your thinking and then do the math. All right, so. $20% more than a number is, I would say, that number is mimicking what we did here. We can't say 40, we don't know what the number is, right? So say 20% more than that number plus 20% of that number. That statement makes sense? Do you understand how that's a little bit of improvement over most of the statements that I saw, although some of them were pretty close? You got to say 20%. Well, you got to say whatever the number is plus 20% of the number, and referring back to that number does it. Now, I can take that statement a step further and say that put it up here. $20% more than n is n plus 20% of n. Okay, that makes sense? Instead of calling it that number, we'll just call the number n. And the meaning of that statement ought to be clear. That means whatever number we want to put in here, if we want to put in 40, we can do 20% more than 40. That would say 20% more than 40 is 40 plus 20% of 40. This statement will work anytime you're talking about some percent more than something, whether it's something you know, like here, 40, or something you're trying to find, like here, the number, okay? Now, how would you write this as a mathematical statement? Kind of like 40 plus 0.20 times 40. But use n instead of 20. Can you write that out? Okay, now some people nailed it, and some people had a little trouble just figuring out what to write out. I probably have figured it out by now, but we need to move on. And of course, you know, you're a distant student. If you weren't in class, you need to be working through this and doing the things that I asked before I show you. Okay, so what do we mean? this means N I'll give you a complete statement. So 20% more than N is N plus 0.20 times N. And you can put a multiplication sign in there if you want, but if you just write 0.20 N, it means 0.20 times N, right? Okay, so I didn't use the times sign like I did here. And I needed the times sign here or some indication of multiplication. So I just wrote 0.2040. That wouldn't make any sense. At least not in terms of the problem. Okay, so 20% more than that is N plus 0.20 N. Right? And that represents this part of the problem. So I'll outline that in green. I'll outline this in green. So we now know that this is N plus 0.20 times N. Now, how do you do the rest of the statement? It says 20% more than a number is 60, right? How would you write that? Could you write that as an equation? Okay, very good. Everybody got it. So now we can say it probably could be written as equation N plus 0.20 N equals 60. Now we can solve that equation, but before we do, we really want to talk about the distributive law. So we're going to go down to these equations here, then we'll come back to this, okay? Now I'm going to dispose of, well, I was going to dispose of it kind of quickly, but I guess maybe I better not. Okay, so take the equation 4x minus 3 equals 2x negative 2x plus 7. If you're doing it without making mistakes, it's okay to then write like -7 here, -7 here. I'd really rather see an equal sign there. -7 equals -7. Then we're adding one equation to the other. Okay. Now, if you're doing that right, okay. And if you're getting the right answers, okay. If not, I really prefer you don't write it that way. Okay. I advise you not to write it that way. I'm not going to count it wrong if you write it that way, but of course, if you make a mistake, you're stuck with a mistake. And some people, and the majority of people, even in pre-calculus, the majority will make mistakes by doing that. Now, it's possible to make mistakes doing what I'm going to show you, but I think it's less likely. Okay, so let's see. We want to subtract 7 from both sides. So I'm going to write 4x minus 3 equals -2x plus 7. And then I'm going to write down a -7 on this side and a -7 on this side. Subtracting 7 from both sides, keeping the equation in balance the way we saw with the weights on the meter stick last class. Okay. Now, what is it that we can subtract 7 from here? Can we subtract 7 from two X?
She was right.
No, because we don't know what X is. Two X could be any number. Okay? This could be any old number at all. We can't subtract 7 from this unless we know what X is, and we don't know what X is. We can subtract 7 from 7, that's why we wrote it. Okay? So we get negative 2X here. Oops. Yeah, let's just be complete. That's negative 2X plus 0. You don't really have to write plus 0, but you have to understand 7 minus 7 is 0. That gives you negative 2X plus 0. And then we have negative 4X minus 3 minus 7. Again, we can't subtract the 7 from the 4X. We can't isolate the 4 and subtract 7 from 4 because 4 is multiplied by X. And we don't know what X is. So we don't know what number 4X stands for. So we can't subtract the number from something we don't know the value of. But we can do negative 3 minus 7, and that's going to give us 4X minus 10. Okay, now it's an unnecessary step to write the 0 there, but for now I'm going to write that just to make sure we understand. And, you know, for the upcoming assignment, I kind of recommend you write out that step instead of just crossing out the sentence. Okay. It's only a recommendation. But you're going to be better off, I think, if you do it that way. Okay. Now, usually we're going to get rid of the X's on the right side, get them over on the left, get the numbers over on the right. I wrote it in this order because I wanted to emphasize that we're subtracting the 7 from the 7, and we're subtracting the 7 from the negative 3. Next thing I want to do is get the X's over here where I've only got X's. Usually we get the X's on the left, but we can get them on the right. That's perfectly legitimate. So we have to subtract 4X from both sides. We do 4X minus 10 equals negative 2X. And then we subtract 4X. Well, 4X minus 4X is 0. And we have the negative 10. So we can write that as 0 minus 10. And negative 2X minus 4X, we can do that because it says whatever X is, we've got negative 2 of them here and negative 4 of them here. That's going to give us negative 6. So we have negative 6X. And then the 0 is really not needed there. So we have negative 10 equals negative 6X. Now we really kind of are used to thinking about it with the X on this side and the number on this side, but it doesn't make any difference. To get X, X is multiplied by negative 6. We can't add 6 and do anything with this. Because we add 6, we can't add 6 to negative 6X because we don't know what X is. Again, we don't know what the value of negative 6X is. So we can't add 6 to something we don't know the value of. So we okay. And what I just said doesn't get us anywhere, it just gets us back to something else we already had. So pretend I didn't say that. That would be legitimate. We could do that, but that's not what we want to do. That's talking about why we can't get rid of the 6 here by adding a 6 because this 6 is multiplied by x. Okay, what we want to do to get rid of this -6 is we write our -10 here, our -6x here, and we divide by -6. And if we divide -6 of something by -6, we just end up with that something. The -6 divides into the 6, gives us 1. So this gives us 1x on this side, and over 6 on this side. And it's not negative. If you're dividing a negative by a negative, that's going to give you positive. Well, now I'm going to reverse sides because you can always switch the two sides. 1x is just x, and 10/6 is 5/3. Now that we've solved it, we check. I take this solution and I plug it in for x here and plug it in for x here, which gives us 4 times 5/3 minus 3 equals, a little more space here, -2 times 5/3 plus 7. And well, this is the same as 4/1 times 5/3 minus 3 equals -2/1 times 5/3 plus 7. And we multiply numerators and multiply denominators, we get 20/3 minus 3 equals -10/3 plus 7. Now we can put the 3 and the 7 over common denominator and see if these add up correctly. We're going to get -1/3 there, and we're going to get 1/3 there. Means I might have made a mistake in my solution. Entirely possible. I was talking more than I was thinking. Let's see. We're going to do it differently, just so you can see one of the principles of equation solving you're going to need for one of the assignments it's going to be due, okay? We multiply both sides of this equation by 3. So first we write down the two sides. Leave ourselves a little bit of room. And we multiply both sides by 3. Notice that I put parentheses around everything that's being multiplied, and I've got to multiply the whole side. Now, when I multiply by 3, that means 3's got to multiply this, and 3's got to multiply this. Similarly, 3's got to multiply this, and 3's got to multiply this. So what we get is 3 okay, 3 multiplied by 20/3 minus 3 multiplied by 3. And that equals 3 multiplied by -10/3 plus 3 multiplied by 7. When I multiply this out, I get 3 times 20/3 Well, this 3 is going to divide this 3, and I guess I'd better write it out. So I'm going to just write it all in the same color. Since I'm multiplying this 3 by a fraction, I'm gonna write it as 3/1 just to keep track of what I'm doing. And the same thing over here. You have a rule that says you can cancel this 3 with this. Okay? But the reason that rule works, and you don't necessarily have to write out the step I'm writing out, but I kind of think it's good if you understand it. This is the same as if I write 3/3 times 20/1, isn't it? Because when you multiply fractions, you multiply the numerators. 3 times 20 is the same here as it is here, right? And 1 times 3 is the same as 3 times 1. It's perfectly legitimate to do that. And then 3 divided by 3 is 1. And 1 times 20/1 is just 20. You divide 20 by 1, you get 20. You multiply that by 1, you get 20. So this becomes just 20. And then this is minus 9, obviously. And that's equal to what? Well, this could be written as 3/3 times negative 10/1 plus 21. Well, again, the 3 divides the 3, you got the 1, you got negative 10. Plus 21, you get 11 equals 11. And now we've checked it. Now you're gonna want to skip a lot of these steps, especially don't understand them. Your rule for cancellation. And I want to see, anytime you cancel, I want you to write out why you canceled. Okay? And in this case, which is maybe a little, it's hard to understand, is this, you can get away with it because 3 is a factor of the numerator. It's a factor. It's one of the things you multiply to get the numerator. So 3 is one of the things you multiply to get the numerator when you do this. And 3 is also a factor of the denominator. Matter of fact, it's the whole denominator. So you take a factor of the numerator and divide by a factor of the denominator, and you can cross them out if you say factor of numerator divided by factor of denominator. Just factor of num divided by factor of denom. Okay? And I really kind of want to see you do that. Because people simply don't understand that when they come into these courses. Most people don't understand that, and it gets them in trouble in later courses. My pre-calculus students think you got a 2 here and you got a 2 over here, you can cross them out. Okay? Some of them, and nobody really would do that. But what I see in pre-calculus classes, people who come in a large portion, probably minority, but a good sized minority, don't understand the rules for cancellation, and almost everybody does it wrong at some point. You can't do it by the way it looks, you gotta do it by the rules, and the rule is you divide a factor of the numerator by a factor of the denominator. Or if you add equal and opposite numbers, or subtract a number from the other. Subtract a number equal and opposite to another number. Subtract a number from the number, you're going to get 0. So that's a legitimate factor, or legitimate cancellation. Okay, so I don't want to go on too long about that, but there we have it. Okay, so this idea of multiplying both sides of the equation by your denominator or by a common denominator is really quite important. Okay. Want to move on to the second equation. When I said we have to multiply 3, when we have 3 multiplied by something in parentheses, if something in parentheses separated by plus or minus signs, then each of those things that's separated by plus or minus signs, call it term. Okay? Now that's standard terminology that kind of gets overlooked when we start teaching people to do math by habit. Okay? But this is a term and this is a term. This is a term and this is a term. When we multiply 3 by sum or difference of terms, we got to multiply 3 by every term. That makes sense? 3 is multiplied by everything, every term in here, everything that's separated by plus or minus from the other things. Okay? All right. So we're going to use that to solve this equation, and it actually comes out pretty easy. So what do we have? Let me back up a second. You always need to be writing out your check when you do a new assignment on a topic. Okay? And you really should be doing that throughout the course. Because if you always check, then you always know if you messed up. Or almost always. Sometimes you can accidentally make a mistake in the check that matches a mistake you made in the problem. And one time out of 100, maybe your check will seem to work, but it doesn't. Okay, anyhow, to the problem. We have the problem 2 times 3x minus 5 equals 4 times 2x plus 6. And I should read that as 2 times the quantity 3x minus 5 equals 4 times the quantity 2x plus 6. Say the quantity, you can say a little more than that sometimes. Okay, well, there it is. Okay, so what happens? Can you write out the next step here? In terms of what I did here. From this step and this step. It's very similar. Except we've got, well, we got some symbols, but that doesn't make a big difference. Now, if you're viewing the video for the first time, hopefully you've written out the step here that mimics the step I did from here to here. Now, what did I do here? And what did I say? Of course, you're not going to remember everything I say. It's coming at you fast, okay? But we had 3 times the quantity 20/3 minus 3. And I said, here's a term, here's a term. The 3 has to multiply this term, but because of parentheses, you multiply 3 by the whole thing, so 3 has to multiply this too. So what do we have to do up here? Now, I don't also recommend that you necessarily skip the stuff I'm going to write at this point. Because, well, you got to multiply 2 by 3x, and you got to multiply 2 by 5. Okay, because 2 is multiplying each term in the parentheses. That's the rule. Okay, then 4 is multiplying 2x, and 4 is multiplying 6. And I can't forbid you, but I strongly urge you to write this step. Don't actually do the numbers until you've written this step and reinforced what it is you're doing. You're multiplying this by this, and you're multiplying this by this. Now, that's a pretty easy rule to get used to. After you practice it a few times, you'll get it. But if you're not writing out this step, later on, when you need it in a more complicated situation, you're more likely to get confused and stumble. So you stop yourself from stumbling later in the course if you take the time, just a few seconds, to write out this step. You also make it easier to check. So if you make it easier to find errors. If you check and find out that your check doesn't work, it helps to have this step to see where the next step comes from. We have 6x then minus 10 equals 8x plus 24. And there we have it. At that point, we've got a problem just like the first one, and we solve it quickly. So I'm going to write down the steps. I'm going to skip a couple of steps. I'm going to do 6x minus 10 minus 24. No, sorry, minus 8x. I'll move the x's over here. Equals 8x plus 24 minus 8x. Okay. I subtract the x's from both sides. Because what that's going to do when I subtract 8x from this 8x, the 8x is going to go away, and then all my x's will be in this side. And then 6x minus 8x is negative 2x. We still have the minus 10, and that equals 24. And then negative 2x minus 10 plus 10 equals 24 plus 10. Once more, if you're making errors by putting the thing you're subtracting down on another line and then doing it, I want it written out on one line. Okay? Not that I'm going to count it wrong if you get it right. You're just less likely to get it right and you're less likely to understand it. Okay? So unless you're doing that right, if you've ever made a mistake by doing the two-line thing and you don't see me doing it, don't do it. Okay. In any case, we get negative 2x equals 34. X equals, well, negative 2x over negative 2 equals 34 over negative 2. X equals negative 17. Now, if I plug in negative 17, okay, I get 2 times 3 times negative 17 minus 5 equals 4 times 2 times negative 17 plus 6. How do I simplify this? Well, by the order of operations, I've got to multiply the 3 by the negative 17 first. So 2 times negative 17 is negative 34, 3 times negative 71, negative 51. Then I do what's in parentheses. I get 2 multiplied by negative 56 equals 4 multiplied by negative 28. The arithmetic is straightforward, but and that gives us negative 112 equals negative 112. And by darn, I did another one right. Okay. Don't skip this step. For the sake of what comes later, don't skip this step. And for the sake of getting immediate feedback when you make a mistake, which is a lot better than not knowing what mistake you made. Okay. You know, you put it into open math and it's wrong. What do? You just go on? Well, no, you check. Okay. And check it before open math tells you it's wrong. Of course, you're going to get the immediate feedback in open math also. But then work the problem out until you check it. If it's wrong, if open math says it's wrong, then you haven't checked. Okay. Then start checking. rework it and check. You learn more and you learn faster and you learn better. Okay. Here we go. So for the camera. Next time you have 3 assignments due, one of them is just doing what we've just done, using the distributive law. Okay. And also, you know, what do you do when you have denominators? Open Math's going to tell you everything I just told you. I'll tell you in a little bit different way. So just make sure you get it. I don't think you'll have any trouble from what I've seen here. A couple of things you needed to know. I think you'll pick them up. I think you'll be fine. There's a section on geometry that I might not talk about today. Because I think you should pretty much know the areas of rectangles and parallelograms and circles, stuff like that. Stuff you've seen, stuff that's not too hard to understand. But then we'll probably talk about it some next time after I see how you do. Okay. But I want to continue talking about equations. Not all equations, excuse me, have numbers in them. Some of them have symbols. So let's take an equation like A equals 2W plus 2H. It's a formula for something that you really shouldn't need a formula for. But it's still kind of useful to have the formula and understand what it means. It's from geometry, it's a perimeter of a rectangle. And I said I wasn't going to talk about geometry, I just happened to do a geometry. It's just this, if you got a rectangle, and this is the width, and this is the height. And how far is it around? Well, whatever the width is, you got to go, if you're walking around it, you got to go W far here, and then you got to go W here, right? That's 2W. And then you also got to go up here and down here, which is 2H. Okay, simple formula from geometry. Okay, so perimeter is 2W plus 2H. We want to solve this equation for W. So what are we going to do to solve the equation for W? Is there something we can do? I'm going to do one thing just to make it a little easier for you to look at. I'm going to switch the sides. Since W, if we're going to want W to be on the left side, so we can end up with a W equals. So it doesn't have to be that way. It could be an equal something and then W, but we usually do it with the thing we're solving for on the left, okay? Just like we usually get our X's on the left. So is there something I can do to both sides to get closer to having just W here? Okay, let me follow up with a question. Is there anything you see now on the left-hand side that you would, you know, that can't be there if you're just going to have the W? And people said, well, H. Yep. What else would you not have? Oh, you don't want the twos. You just want plain old W, right? So what do? Well, usually we're going to look for something that we could add or subtract. And if not, then we look for something to multiply or divide. Okay. So ask what would we add or subtract? And somebody said, well, subtract the 2H's. Exactly what we do. We do 2W plus 2H equals P. We don't write anything underneath unless we're really secure to understand what we're doing. Always might be. Not sure about the distance to you. everybody's doing homework in the distance is doing real well. So hopefully they understand as well. Okay, so we subtract two H from both sides. Okay, I don't know about people in distance, of course, they're not doing anything. If they haven't done anything as of tomorrow, it won't be a course anymore. Okay, so we subtract two H from both sides. Okay, well, what's two H minus two H? Can you show me with your hand? Zero, right? When you subtract something from itself, it gives you zero. Just effectively cancels it out. People like to use that word. Okay, so we've got two W equals P minus two H. Now what do we do? How are we going to get W? Okay, so what can we do to both sides to get closer to W? Well, we can get W. We can write, now normally we do this in one step, but we're going to do it in two steps. We write two W, you know, we're going to divide, so we put the equal sign a little lower. And we have P minus two H. If we divide both sides by two, well, 2 is going to divide the 2, and we're going to get W equals P minus 2H over 2. So we just solved the equation for W. So now if I tell you, I've got this rectangular field, and I know that if I walk around it, it takes me 1,000 paces. And I know that the length of the field is 300 paces. Okay, well, what's that tell me? It tells me the perimeter is 1,000 paces. Okay. Well, let's say I know this dimension. Okay, let's say this dimension is 200. Okay. If I know P and H, then I can find how wide it is without having to pace it off. Now, if I've already paced all the way around it, you would think that I would be able to remember how long and how wide it is, but maybe not. Maybe I paced all 1,000 paces and didn't stop and think, well, how far did I go here? Okay. So what I do is I pace off this side, and now I know P and I know H. And now I can just do W is P minus 2H over 2. Okay. Okay, well, there's a little caveat there. I'm not going to bother to mention it. We're just going to leave it out. And so here's another one. I've got a circle. Its radius is R. And its circumference is 2 pi times R. Very common, fundamental geometric fact. Bad looking circle, but that is a good one. Okay, the circumference is 2 pi R. Circumference means how far I have to walk to go all the way around the circle. So I can write C equals 2 pi R. But if I've got a circular boundary or some circle, I can walk around it and see what the circumference is, right? It's a lot easier to do that than to try to figure out where the center of the circle is, so that I can pace off the radius. Okay. Not only that, but maybe that's a lake or something. I don't want to have to swim to locate the center. I could probably swim straight across it, and if I know how far I go in each stroke, then I could figure out the radius. It'd be half the diameter, so I could go all the way across, but of course I'd have to go at the right point. I wouldn't want to go across from here to here, or from here to here. I'd have to go across like from here to here, from here to here. I'd have to go through the center, and since I don't know where the center is, that might not be the best strategy. So I've got this circular lake. And I know the circumference. How am I going to find the radius? I don't see, how do I find R? Well, C equals 2 pi R is a perfectly good equation. So I write C equals 2 pi R. And then maybe I kind of target R, a little circle around R. That's what we're trying to isolate, right? So what could I do to get R by itself? Okay, so what do we do? Well, hint, here, listen student or somebody in this class watching this. There are no pluses or minuses anywhere here, so adding or subtracting isn't going to help. Like over here, we could subtract a 2h because it's added. Okay. Once we get down to 2w, we're down to multiplication or division to isolate w, so we divide by the 2. Okay, over here, one suggestion we got, okay, well, what would you multiply or divide by to get closer to having R by itself? I had a suggestion, well, divide by C. It's a legitimate step, but it takes us further from our goal of isolating R. Okay, if I divide by C, I get C over C, which is 1, but then I'd have to have 2 pi R divided by C. That's cluttering up the side that has R on it. Okay, so it's a legitimate step. It's a good suggestion, but it's not the one we're going to follow up on. So what we do is we divide by the 2 pi. So we do C divided by, and we do 2 pi R divided by, and we got to divide by the same thing. So we got to put the same thing here as we put here. Okay. So that gives us C over 2 pi. And if we're dividing 2 pi times R by 2 pi, the 2 pi will divide the 2 pi and leave us out. So just essentially one step. And maybe we want to say R equals C over 2 pi. As I said over here, usually say we're solving for what we want on the left. But that's trivial. We just switch the sides and it's still an equality. If that side of the balance is equal to this side of the balance, and that side is equal to this side, then if I switch them, they're still equal. Okay. Okay. So, okay, another formula from geometry. These actually make good examples. Before I put the geometry right before them. Let's say this is L. Well, I guess we'll make this H. We'll take this W, we'll make this L, and we'll make this H. Then the area, total area, is two WH plus two WL plus two LH. And the reason for that is pretty simple. If you look at this face, the front face of the solid, we have we have an area, we have a rectangle with W line face. So if we multiply the two dimensions, W times H, that gives us the area of the front. The area of the back is the same as the area of the front, so we have two of them. If we look at the right face, its dimensions are L by H. So to get the area of the right face, we multiply L by H. But the area of the left face is the same as the area of the right face. We have two L. In the top and bottom, the bottom is W by L, so its area is W times L. And we got the bottom and the top that are equal, so we got two WL. So we're little geometry into this. So we can solve this. Let's solve that for L. Okay, what's the first thing we want to do in solving this for L? All the L's are on one side, right? We got L, and let's identify L. We got L here, and we have it here. Is there anything on the right side that we can get rid of easily? Okay, we would have probably add or subtract something, so we've got some additions here. And since all these are additions, we're probably going to subtract something. What could we subtract to get closer to isolating L? Well, think about it. Subtract two WH from both sides. That won't be on this side anymore. So we're going to subtract that. We're going to do A minus two WH equals two WL plus two LH. Oh, sorry, I didn't write that. That's what we're going to get. But I really should be writing that out. Okay, well, I've got two WH here and minus two WH here. So the two WH is going to go away on this side. We got A minus two WH equals two WL plus two LH. Now, after you, I'm not sure all that is visible, so let's look again. Okay. Again, we have what I said. A WH is the area of this face because it's W by H. And we have the front and back face with areas WH. We got two WH. The right face is L by H. So its area is LH. And the left face has the same area. That's also two LH. That's also LH. We got two LH. The bottom is W by L. Its area is WL. And the top has the same area, so we have two WL. Now we're solving for L. Okay, we look at this and look at what we can eliminate. So we say, okay, let's see, this thing doesn't have L in it. I kind of circled the L's, make sure I see where all the L's are, okay? This one doesn't have any, so I'm gonna get rid of it. To get rid of it, we gotta subtract it. So we subtract that from both sides. Get A minus two WH, and then we get this whole side, and then we'll minus two WH. Two WH minus two WH is a zero, subtracting something from itself. And here we have this. Now there's this step that I wish I had a little more time to explain, but I'm going to just tell you that this is equal to L times two W plus two H by the distributive law, because if I multiply through here, I'm gonna get two WL. And then I'm gonna get two LH. Okay, when the L is multiplied by both terms, I get back to what I had here. Now this is called factoring, and you're probably gonna see that when we get to the section formulas. But it's a pretty simple factoring. It's just the distributive law. Okay. By the distributive law, this has to equal this. And I haven't changed this side. So there we have this. Well, now if I want to get L, I divide by 2W plus 2H. And of course, I got to do that on this side. And now I get L equals this. Now, fair warning, you can't cancel this H with this H because this H is not a factor of the denominator. It's not something that's multiplied through in the denominator. And this H is not a factor of the numerator. And this is where we really get into problems with canceling, because people want to cancel this H and cancel this W with this W and cancel all these twos. And it doesn't work. Okay. So that becomes a problem. So that's just fair warning. Okay. So we did manage to talk about both formulas and geometry in a way that I think is going to help you. Okay, well, good luck with the assignments. Run into, hang up, email me, let me know, and ask a good question. I'll be glad to